Okay, this is about how to reflect points. Now, suppose we have a quadratic equation. It's y equals negative 2x squared plus 4x plus 4. So the axis of symmetry is minus b over 2a, and so that's going to equal minus 4 over minus 4, or 1. So the axis of symmetry is x equals 1. Axis of symmetry. Okay, so let's go down here. Let's draw a graph. And we'll go to 1. And we'll put in our axis of symmetry. Now, you can tell from the equation that the y-intercept is 4. 1, 2, 3, 1, 2, 3, 4. So at 0, 4, we have the y-intercept. Now, x equals 1 is the axis of symmetry. And if I plug in 1 into the equation, so I'll get y, the y-coordinate of the vertex will equal negative 2 times 1 squared plus 4 times 1 plus 4. And so that's going to be 6. Okay, so I go up to 6, and so the vertex is 1, 6. All right, now here's the axis of symmetry, here's the vertex, and I have the y-intercept. So I want to reflect the y-intercept, which means I want to graph the point that has the same y value as the y-intercept, which is 4, but I want it to be on the other side of the axis of symmetry. Now, 0, 4 is 1 unit to the left of the axis of symmetry. So if I go 1 unit to the right and count up 1, 2, 3, 4, okay, then I have the reflection of 0, 4 at 2, 4. Notice that 0, 4 and 2, 4 are each 1 unit away from the axis of symmetry. Now, you can also do this, you can do this in a table, and in some ways it's easier in a table than on the graph, or some of you might like the graph better. Okay, so I'm just going to put in some numbers here, and I'm going to put the axis of symmetry in the middle. So here's 1 and 6. And so then we graphed 2 and 4. And so you can see now this is the axis of symmetry. So we'll label that point. So if I go to 0, you can see that 0 is 1 above the axis of symmetry and 2 is 1 below. So they should have the same x-coordinate. Now let me go to the next number in the table. Let's do 3. Okay, and so I'll plug in y equals negative 2 times 3 squared plus 4 times 3 plus 4. So this is negative 18 plus 12 plus 4. 16 minus 18, which is negative 2. So for x equals 3, y coordinate is negative 2. So 1, 2, 3, and negative 2. Now this is 2 units away from the axis of symmetry. 2 units to the other way is negative 1. And you can see if I go to negative 1, okay, now you can see that the y coordinate will be negative 2. So negative 3 and negative 2 is reflected by negative 1 and negative 2, and vice versa. And so now I've got these 2 reflected points. They're each 2 units from the axis of symmetry. And this is 3, negative 2, and this is negative 1, negative 2. And so that's how you reflect points. And so by using the quality of symmetry, that quadratics have, you can very easily come up with 5 points that you need to graph. You don't have to do a lot of other calculations. You find the vertex and the y-intercept reflected, find one other point, reflect it, and you're all set. And that's